Module 3, Objective 9, discuss the effects of exercise, hormones, and nutrition on bone development and on the skeletal system. In terms of bone, we know that exercise has a great effect on bone. Mineral recycling allows bones to adapt to stress. By minerals, we're mainly considering calcium and phosphorus or phosphate. When we heavily stress bones, and here we're talking about exercise, stressing a bone, contracting muscles, and as those muscles pull on the bones, you stress the bones. When you exercise, your bones become thicker and stronger, particularly through weight-bearing exercises. You stimulate osteoblasts to lay down more osteoid. Remember, osteoid is the non-calcified matrix, so mainly collagen. I think there's an I in there. And bone degeneration can be very quickly. You can lose up to a third of the bone mass if you stop using muscles within just weeks of inactivity. Anybody who's ever suffered a broken limb, such as this picture represents an individual who had broken a thigh bone, a femur. They had casted that, and you can see that there was a tremendous musculature atrophy, so that the muscle has atrophied, it has decreased in size. But you can also expect within weeks about a third of the bone mass can also be lost. In terms of nutritional and hormone effects on bones, we've already noted within the matrix of bone, we have a lot of calcium phosphate. So we have to get that dietarily. Remember that anytime you consume calcium and phosphorus, you really need vitamin D in order to absorb those minerals across the digestive lining into the blood. And we know that vitamin D is made within the integument. We do get it dietarily, but it's also made in the integument, where the cholecalciferol is then converted into calcitriol by the kidneys, and that's required for the absorption of calcium and phosphorus across the digestive lining. So eating calcium or taking calcium supplements isn't enough if you don't have the vitamin D3 in order to absorb those. So calcitriol, vitamin D3, they're essential for the normal calcium and phosphate ion absorption in the digestive system. In addition to calcium and phosphorus, we do have some trace minerals that are also required, such as magnesium, fluoride, iron, and manganese. In terms of vitamins and some hormones, in addition to vitamin D, vitamin C, A, K, and B12 are also very important for bone health. Vitamin C is required for collagen synthesis. So in order to synthesize collagen, the non-cellular component of the matrix, or the organic component of the matrix. Vitamin C also stimulates osteoblast differentiation. Remember that the osteogenic cells differentiate into osteoblasts. Vitamin A stimulates the activity of osteoblasts, and vitamins K and B12 are required for the synthesis of bone proteins. Hormonally, we have two main hormones that stimulate bone growth. They include growth hormone and thyroxine. Thyroxine is one of the thyroid hormones, and it's directly related to metabolism. Growth hormone is a pituitary hormone that helps with growth. So growth hormone helps with bone growth. It also helps with other types of growth, such as muscle growth. Sex hormones, such as estrogen and testosterone, are used to stimulate osteoblasts. And then lastly, we have a pair of hormones that help regulate calcium homeostasis. They include parathyroid hormone. This is a hormone secreted by the parathyroid gland, as well as calcitonin. Calcitonin is secreted by the thyroid gland. And these two hormones are antagonistic. They work together. One is going to raise blood calcium levels. The other one is going to lower blood calcium levels. So they're constantly battling it out in order to maintain homeostasis with respect to calcium ions. Here are two pathological conditions associated with growth hormone. Again, growth hormone is secreted by the pituitary gland. And when we talk about pathologies associated with hormones, you really only have two options. You can have a hyposecretion, where you don't have enough growth hormone being secreted. And in the case of hyposecretion of growth hormone, you end up with pituitary dwarfism. So you don't get the growth that would be associated with a normal secretion of growth hormone. Hypersecretion of growth hormone is associated with gigantism. This picture is of Robert Wadlow. He grew up in the Midwest, and he was sort of a local celebrity. And at his death, he was 8 foot and 11 inches tall, so tremendous height. And the problem that these individuals, these suffering from pituitary gigantism, is while their body is growing, so their bones and their muscles have grown tremendously, a lot of their internal organs are not affected by growth hormone. So their heart and their livers and their kidneys, they're normal size. So they're overtaxed. It's almost like trying to cool your entire home with just a window unit air conditioner. It just doesn't have the capacity to do that. So these individuals are short-lived. I think Robert Wadlow died in his 20s, mainly from organ failure. So the heart could not keep up with the size of the body. And that's a very prominent cause of death from hypersecretion of growth hormone. So again, hormones, you either hyposecrete or hyper. Those are the two pathologies. A hyposecretion of growth hormone leads to pituitary dwarfism. A hypersecretion leads to pituitary gigantism.